Hi everyone. In my earlier video, I had shown different types of service in Kubernetes and how it works and its internals. I hope everyone had a clear understanding of different types being used in service. Load balancer and node pods are widely used to expose the application to the external world. Many companies use either load balancer type or node pod to expose the application to outside. However, I am not sure how many of them know the problems associated with these two types of service. As I showed in my earlier video, both load balancer type and node port creates the same kind of iptable rules on all the nodes. So in effect, the problems are the same for both of these service types. In my discussion, I will be referring load balancer type, but all the problems being discussed here are applicable for node port as well. So here is the agenda. So we'll be discussing about the problems associated with the load balancer type and node port and how to mitigate this problem, and followed by a demo. What is the first problem? First problem of course is with IP table rules because there will be a NAT session created for every client request. NATs being created even for east-west traffic as well. So if the node has a lot of NAT sessions, which will impact the performance. However, we can ignore these performance aspects. But if you have lots of east-west traffic and front-end application performance is going drastically, and you don't want your client to face any delay of accessing your application, then expose the application ports directly to the load balancer. I will cover this session in some other video in which I will show what is the best load balancer you can use for boosting your application performance. The important and main problem with load balancer or node port type is, let's say, if a node rebooted or become unresponsive, the end user will face service unavailable error, even though we have a large number of working nodes. In my demo, I will be showing this case. This issue is due to iptable rules. Kubernetes takes a while to detect node reboot case. Because of that, iptable rules will be present in all other nodes. So when a request lands on an active node, the queue proxy might send the packet to the node which is not ready. This issue can be mitigated by setting external traffic policy as local in service. However, this has its own drawbacks. The main drawback is your application won't get a fair load balancing, which means some nodes might be loaded heavily and some may not. It all depends on the replicas and how the pods are distributed. Now let's move to demo. So this is my Kubernetes master node. There is no pods running in this master node. I have a cold ring application. The service type for this cold ring application is load balancer. Now we will deploy this cold ring application, and I will show you the number of nodes I have in this Kubernetes cluster. I have 2 nodes. So the application is running and it has an external IP. We will access this application from my browser. You can see the application is accessible. Now we will reboot one of the worker node because these pods are distributed across 2 nodes. One is in worker node 1 and another is worker node 2. So we will reboot this worker node 2 and see what happens. I'm rebooting the worker node 2. You can see here the Kubernetes is not yet detected the status of the worker node 2. It is still showing as ready. You can see we are not able to access the application. This is because kubeproxy sent this request to the inactive node. The reason is the Kubernetes nodes, it takes a while to detect the worker node as not ready. After that only the Kubernetes update the iptable rules. Till then, even if you have another active working node, the packet might send to the non-working node. This will create a service unavailable error to the user. Now we will deploy the same application using the external traffic policy as local. Nodes are ready now. build the application again using this IP. The application is accessible. Now we'll go and reboot the worker node. We are rebooting the same worker node. Now if you access the application again from another window, you can see the application is accessible. This is because we set the external traffic policy as local, which means the Kubernetes will try to serve the traffic from the same node. So the kubeproxy will not do its own load balancing and it will not send the packet to other node. So this is the point which you have to remember when you are planning to move your application to production environment. You have to always keep external traffic policy as local. Otherwise, in case of not reboot case or unresponsive case, the end user will not able to access your application. Thank you for your time.